that. And we're recording. I need my speakers off. And there we go. So down in this bottom corner at page 35, sort of right there. Yeah, I haven't turned that on yet, have I? There. Okay. Come on. Let's go. Let's see this thing. There we go. Sorted down here. All right. Let me ask you a couple of things. One, what does that mathematical expression mean? Right. So what does it mean? 5 times x, right? Easy peasy. Yeah? Now, maybe in grade 9 you learn that thing where x's, we draw them as a bar. You guys seen that? We'll do it later. But anyway, this just means there's 5 of whatever x is, right? It's not x to the 5th, it's 5 of them, because this is multiplication, yeah? So this means not x times x times x. No. It means simply that there are 5 x's, because that's 1x and there's 5 of them. Cool, right? Okay. Now, if I come over right beside here and I write 3x, what does that mean? 3 x's. Excellent. Now, if I add them, what do I get? 8x, because 5 and 3 is 8. Cool, right? Easy, we all know that, yeah? What did your grade 9 teacher call doing this? Pardon me? Yeah, they are monomials, but what did he call, or she, if you had a lady teacher, what did they, to keep the pronouns good, what did they call what is highlighted there? Jacqueline? Okay. I'm asking the question poorly, obviously. This is called collecting like terms, which you have all heard before or should have. Right? What is it about what is highlighted in yellow that makes it collecting like terms? Braden. They both are an X. Okay? Now, let me ask a couple of questions. Just think in your head yes or no. Collecting like terms, yes or no? No. Why not? Jade. Because there's an exponent, right? Excellent. Now, if this was multiply, could we do it? Yeah, because that was the exponent unit we just did, right? It would be 15x cubed. But this is addition, so we can't. So that's a no because of the exponent. Yeah? Okay. 3a plus negative 4a. Yes or no? Yes. Why? Because they're both a, so this answer would be negative a. So that's a yes, right? Everyone is good? Okay. 5x plus 3a. Yes or no? No. Why? Because the x and the a are different. Everyone's cool, right? This is not news to anyone, yeah? Okay. Now, if this means 5 times whatever that is, then doesn't it follow, isn't it logical, that this is the same as 5 root 2? Makes sense, right? 5 times x, so what's this? What does this mean? If this means 5 times x, what does this mean? 5 times root 2. Right? It's logic. It makes sense because math follows the pattern. Everything works. So logically, what then would be 5 root 2 plus 3 root 2? Eight root 2. Because this and this are the same thing. Everybody understand? So, let me ask you this. Could I do this? 5 root 2 plus 3 cube root 2. Could I do that, do you think? Why not? Yeah, it's just like the exponents. The thing that is being multiplied is different because the square root of 2 is not the cube root of 2. Everybody cool? And there was a whole page of notes on that, but that's what it boils down to. Everybody good? Okay, so that's good. That makes me very happy because it's going to make today very easy if everybody really believes me. So let's remind you, 5x behaves like 5 root 2. Anybody remember the fancy math name for this guy? Coefficient. Which makes this guy a coefficient. And coefficients do what? What math does a coefficient do? Multiplies. This guy is what we call an argument. And this guy is what we call an argument. All right? So there's some new words. We're cool. Multiplying radicals can only occur, please underline only, occur if both radicals have the same what? What is it, do you think, in these two radicals that allows me to multiply them? What do you think it would be? Remember down here, what did we have to do before we could add them? Because adding is just multiplying, right? Or multiplying is just adding. So what is it about this line that makes that okay? The argument has to be the same, right? Now, so this and this has to be the same, right? How many parts are there to this expression? There's 2 parts. There's the radicand, right? And the index. Agreed? So when we're adding, they both had to be the same. Everybody cool? Just like when we're doing letters, right? But when we multiply 5x times 3x squared, can we do that? We can, can't we? Because the numbers go with the numbers and the exponents or the argument goes with the argument, right? Okay, so that we know would be 15x cubed, yes? Can we do this? 5x times 3y. Can we do that in multiplying? We can't do it in adding, but can we multiply that? Yeah, we can. What's the answer? 15xy, right? 15, 3 times 5, and then x times y. Agreed? Now, if this behaves just like this, then to add, the arguments have to be exactly the same, don't they? But to multiply, do they need to be the same? No. So, these guys could not add. That would be a no, because x and y. But root x times root y, that's a yes, because these behave the same way. Everybody cool? So, multiplying, and I'm going to highlight multiplying, can only occur if both radicals have the same index. addition, the arguments must be the same. Everybody cool? That's the stuff that was on that extra page. If I'm going to add them, they got to be exactly the same, just like 5x and 3x, or 5x squared and 3x squared. Braden. I'm about to show you that. Okay? So, but we're going to start with just numbers first. Okay? So, here is what you do. All you have to do is multiply the coefficients together and arguments together, just like in exponents. The numbers go with numbers, the letters go with letters. So, coefficients are green, arguments are blue. Where are the coefficients in this first one? Gersa Hill. Outside the radical. And what are they? -7 and 5, right? So, first step is to multiply the coefficients together. So, what is -7 times 5? 35. -35. Now, I'm showing everything, and I know I always tell you to show your work, but do you really need to write this out? You could just write 35, couldn't you? Everybody understands that, yeah? Okay. And where are the arguments? Inside the brackets, root 3 and root 8. Or not the brackets, the radicals. So the arguments, which I'll do in blue, is root 3 times 8, which is 24. Now, is that the final answer? No. Is it an answer? Is that technically right? Will you do more math? Yes, because when do we stop doing math? When there is no more math we can do. And we know what to do with root 24, don't we? What is root 24? We've just done 2 pages of it. What should you do with root 24? Nope. Break it down. Make the tree. But we practiced it a bit. I'm not going to do the tree because we know that's 4 times 6, yes? What's going to happen with that 4? It's going to become a 2 out here, right, Jade? And once something is out front, what has it now become? It's become a coefficient. And what do all coefficients do? Multiply. So I got 2 times -35 to get -70 root 6. Does everyone understand? It's pretty simple, right? Numbers with numbers, letters with letters. Numbers with numbers, radicans with radicans. Okay? Now, Braden, I still have your question right here in my head. And I'm going to discuss it very, very soon. Okay? So don't worry. Okay? I got you. So what about this one? What are the coefficients? Well, there's no coefficient there, so it's 0, right? No, what is it? 1. And that. Do I need to write 1 and 3? We're in the 10th grade. We can multiply 3 times 1. It's 3. Then, root what? Two and 8. What is it? 3 root 16. Would we stop? No, because what is the root of 16? 4. So what's coming out here? No. 4, because the root of 16 is 4. And what is this answer? 12. Now, Gersil, your problem there is this is 4 times 4, yes? So you're bringing out the pair of 4s. Over here, you only had a single 4, so you brought out the square root of 4. All right? Everybody cool? All right, it's still here, Braden. It's coming. But I got to do 2 more before we get to it. So what's this guy? What are the coefficients? Negative 8 and 6. We can do that in our head. What is it? I'm going to write negative 8 and 6 while you guys are actually writing the answer. What is it? You all know your times tables. Right. Negative 48. And in blue, 72. And of course, we don't stop there, right? So what does 72 break down into? You could do 9 and 8. So we could have 9 and 8. And then 8 would be 4 and 2, correct? So what's the square root of 9? So what comes out here? What comes out? 3. And what's the square root of 4? What comes out? What's 2 times 3? And then what do 6 and negative 48 have to do? Multiply. That's a big number. I don't want you to waste your time with your calculator because it's just multiply. I'm going to give it to you. It's negative 288. And what did I leave under the radical sign? 2. And we're done. Is everybody cool? All right. Now we're going to add a wrinkle to it. We're going to answer Braden's question because this is a really easy one. Okay? Let's do this one the way we've been doing it already, and then we'll do Braden's wrinkly question. Okay? Normally, this is 3 times 1, right? Right? So it's 3. And the root of what's 3 times 3? 9. What is the square root of 9? 3. So what comes out here? 3. Was there anything left under there? No. What's 3 times 3? 9. Everybody cool? Take 2 seconds, did it in your head. Now let's change it slightly so it's what Braden was asking about. 3 root 3x times root 3x cubed y. Well, the 3 and the 1 is the same, right? Everyone agrees? Yeah? So it's still going to be 3. And under there, what is 3 times 3? 9. So we're still the same. What is x times x cubed? X to the 4th, because we just did a whole unit on exponents, yes? And what is that times y? Just a y. Now you already know what to do. What's the square root of 9? So what's coming out here? 3. How many x's can I get out? I'm looking for a group of 2, right? I can get out 2 x's. Any x's left there? No, the x's are done. The y's are done. Can I get any groups of y? No. So it's 9x squared root y. Now notice what has happened there. We've taken our first part of this unit and brought it to the second part of this unit. Everybody cool? Good, Braden? That was what you were asking, right? A good thing I kept it in my head. Okay. Everybody cool? We already knew what to do with this. All you needed to be taught was you just multiply the radicands, right? Okay. So let's look at the E, because E is now both of the things you've learned today. It looks freaky, but remember, if none of that was there, what would you do with that? Multiply, and what would you get? 15 root 16. Easy peasy, right? Okay. Now, that's not there. and that's not there. What do you get? Plus 10 root 24. Now, that's not there, and that's not there. What do you get? I'm going to pretend that my grade 10s are not all silent when they have to do 5 times -1. I'm going to pretend that all 26 of you are saying the answer right now, and I just can't pick it. Simrith, thank you. And I'm going to pretend that all of my grade 10s are yelling the answer of 8 times 5, because it's exactly the same thing as we've just done 27 times. What is it? 40. And of course you remember that from the 9th grade as well, because all I just did was distribution, right? Now, would I leave that answer? Of course not. What is the square root of 16? 4, so what comes out here? 4. What is 4 times 15? 60. Would I leave root 24? We've already done root 24 on this page. Find it. It's 6 times 4. What's the square root of 4? So what's coming out? 2. There's already a 10 there, so what is it? 20 root what? 6. And what's 40? 10 and 4. What's the square root of 4? So what's coming out? 2. What's already out there? So it's -10 root 10. And I would be done. Everybody cool? Now, look at F. What's different looking? Jacqueline? It's cubed root. Will we do anything different in our math? No. So, first of all, are there any coefficients? So it's 1 times 1, so it's 1, right? Now, up until now, we've been doing this, right? So how many of you want to do the root of 16 times 54? If you did that with your calculator, you'd get the cubed root of 864. And that would be a big factor tree, wouldn't it? Be huge. Do we need to? No, of course not. Why? Because I've already got 2 factors right here, don't I? What is a perfect cube that works with 16? 8, because that is 8 times 2, isn't it? What is a perfect cube that works with 20? I just gave it away. What is the perfect cube that works with 54? That's 27 times 2, right? What's the cubed root of 8? 2, so what comes out here? 2. What's the cubed root of 27? 3, so what comes out here? What do these numbers do now that they're coefficients? Multiply to get 6 cube root, and what did I leave under there? Look close. 4. I left 2 2's, right? Everybody with me? That's one way you could do it. Another way you could do it is simplify first. You could simplify up here and get 8 and 2 and 27 and 2. So this would be 2 cube root 2 times 3 cube root 2. 2 times 3 is 6. Cube root 2 times 2 is 4. Does it matter which way you do it? Who has to make the decision? You do. But it's the exact same thing, isn't it? Either I'm simplifying here and pulling out the groups, or I'm simplifying here and pulling out the groups. If you really wanted to, could you even do the giant factor tree? You could if you wanted to. Would I ever stop you? Would I ever say, no, kid, that's dumb? Never. Would I say, couldn't you be more efficient? Because isn't simplifying 16 and 54 easier than simplifying 864? I think yes. We are going to do this last question, and then we are shutting up. Now, do you want to do 28 times 63 and simplify that? I sure as heck don't. But I can do 5 times 3, can't I? So that is 15 root 28 times 63. Because I don't want to simplify the big number when I can simplify little numbers, right? So what is that? How would I break down 28? I would use 4 and 7. Why 4? Perfect square. What would I use with 63? I would use 9 and 7. Why 9? Perfect square. So what's coming out from the 4? 2. What's coming out from the 9? 3. What's left? Hey, it's 2 7s. So what's coming out? A 7. Was there anything left under there? No. But I got to do this big math. But it's not big math. What's 15 times 2? What's 30 times 3? What's 90 times 7? 630. Because 9 times 7 is 63, and then we add a 0. Does everybody see how easy this is? It's what you already know because you know how to do all this stuff over here. Everybody good? Listen to me and listen to me carefully. It is 9:19. You have 10 more minutes left in class. Tomorrow you are writing a quiz that is only exponents and simplifying radicals. No adding of them, no multiplying of them, okay? I don't think there's any estimating on there. I can't remember. Everybody cool? Tomorrow in class, we are going to do page 36. And do you see how it says the word assignment? So what does that mean? It's going to be marked. So tomorrow, you're going to write that quiz. We're going to mark it in class. Then for the rest of the class, we are going to work on this page. And then we're going to mark it in class tomorrow. Everybody understand? You have 10 minutes now. You can get a head start. I do not care. But we are going to work on this tomorrow. Do not leave yourself with more than about 15 minutes of work tomorrow. Because I'm only going to give you 15, maybe 20 minutes to do this page. So if you leave it completely blank right now, you waste the next 10 minutes. You might not get it done tomorrow, and it's 4 marks. Does everyone understand? All right, go.